Hey, this is Mr. Soy. I wanted to do a quick example of how we can find the features of a quadratic graph to help you with the worksheet that has a bunch of graphs that you need to identify all the various pieces of. One of the things that's important is you got to remember that features of the graph oftentimes are represented inside some of the equations. And if you did the last lesson of the chapter, you would have a clear understanding that. But at this point, we're just looking at the actual graph itself and we're looking at the actual features. I'm going to go ahead and mark some of the features on the graph right now. For example, right here, that would be my y-intercept. Here would be an x-intercept. This would also be an x-intercept. And then this up here would be the vertex. And that's going to give me pretty much everything I need. So let's take a look at how we can do this. Let's start with our y-intercept. So our y-intercept, when I'm looking at it, is simply going to be y equal negative 4. That's essentially the y-intercept. At the y-axis, our graph crosses at negative 4. Next, we're going to look at the x-intercepts. Our x-intercepts, well, you can see that they're kind of in between. When they're in between like that, best thing to do is let's just assume that they're going to be halfway between two different points. So it looks to me like it's negative 0.5 and then negative 3.5. And I can write that as x equals negative 0.5 and x equals negative 3.5. All right, so far so good. Now I'm going to turn my attention to the vertex up here at the top. And the vertex is really a point. So an xy, well, it looks to me like it's at x equals negative 2 right here, and then at y equals 4. And so I can write that vertex then as a point, and that point is going to be at x equals negative 2, y equals 4. Excellent. So that's the first part of what we were asked to do here. Find the x, y intercepts, and then the vertex. Here it says point of extremum, circle 1. Well, essentially, that is the vertex. That's our extremum. And in this case, because the parabola is pointing down, opening down, then this would be the maximum. That's the extremum that they're talking about, the maximum. And we always take the y value of the vertex, and that becomes then that point of extremum. In this case, I'm going to write that out as our max for this function is positive 4. That's our maximum. All right, so let's move on. Now we've got this idea of axis of symmetry, roots, solution, and zeros. Well, it turns out roots, solutions, and zeros are, all three of those are the exact same thing. But let's first start with our axis of symmetry, x equal. The axis of symmetry is where we split the graph of the parabola in half, and it always passes, so it's a vertical line always passing through the vertex of our parabola. So to create a vertical line, it's going to be x equal, well, in this case, it's x equals negative 2. And so I can now write that in. So my axis of symmetry, so axis of symmetry is x equal negative 2. Because if we draw a horizontal line through x equals negative 2, vertical line through x equals negative 2, we will have then the axis of symmetry. And now finally the roots, solutions, and zeros. Okay, well, our roots, it turns out, are r1 equal negative 0.5, and our second root, r2, is equal to negative 3.5. They're the x-intercepts. That's it. The solutions are the exact same thing, except we will write them as x equals negative 0.5 and x equals negative 3.5. And then finally our zeros. Well, our zeros are essentially the same thing. They are going to be negative 0.5 and negative 3.5, and that's how we would write them out. And that's pretty much it for finding the features of a quadratic graph. Step one, make sure that you identify on the graph all of the points that are important, our y-intercept, x-intercepts, and our vertex. And then from that, we can then derive all of the information we need for these features. Hope this helps. Thanks.